All right. Okay, so this one says graph the function. All right. So this is a function, it's a quadratic function given to us in standard form. So we have a of -1/5. You have b, which is 2, and c is -4. So when I'm in standard form like this, one of the things I might do is kind of find the vertex. So the vertex when you're in standard form, so the vertex, the x value, or so the to find the vertex, the x value is -b over 2a. So I'll say x equals -b over 2a. So to find the vertex, the x value is going to be -b over 2a every time, as long as it's written in standard form. So here, the x value of the vertex is -2, that's -b, over 2a. So 2 times -1/5 is -2/5. So the x value of my vertex is -2 divided by -2/5. So it's kind of a little messy, but I know that if I divide by a fraction, you can actually just multiply by the reciprocal. So it's going to be -2 times -5 over 2. So instead of dividing by a fraction, you can multiply by the reciprocal. It's the same thing, or that's how you would divide by a fraction. Now I have -2 times -5 over 2. I can put the -2 over 1 if I want to make it look like I'm multiplying two fractions. So that's going to give me, on the top, it's going to give me 10 positive. And on the bottom, it's going to give me 2. And 10 over 2 is 5. So that was a lot of kind of complex math, and maybe a calculator might help there, but the vertex is where x equals 5. I do not know the y value. I would need to plug in that number 5 for x. So what I'm going to do is I'm going to find f of 5. So I'm going to find out what's the value of the function when the input is 5, or when x is 5. So to do that, it's going to be -1/5 times 5 squared. 5 squared is 25. So it's going to be -1/5 times 25 plus 2 times 5, which is 10, minus 4. So the y value, it's what's a fifth of 25? That's 5, and it's going to be negative. So it's going to be -5 plus the 10 minus the 4. So -5 plus 10 is 5 minus 4. That was a lot of math to get 1. So the vertex is at 5, 1. So the vertex is the either the top or bottom of our graph, depending on which way it's facing, but 5, 1. That's where the vertex is going to be. X is 5, y is 1. And I know that the y-intercept is just going to be c in standard form. The y-intercept is going to be -4. So in this case, I can kind of simply just put this point at the y-intercept of -4, down there at -4. So I know I only need 2 points when I'm graphing on Khan Academy with a quadratic. I need the vertex. So the vertex is 5, 1. You can see the process I used to get that, and then the y-intercept is -4. So you could have done this in a different way, but I think that's a pretty standard way that's going to work for all, if not, most of them. So, alrighty, all right. So this one is asking us to solve, and it looks like all the answers are in the form of using the quadratic formula. So what I'm going to do is I am going to rearrange the terms here. I'm going to collect my like terms, and I'm going to write this in standard form. That's going to allow me to use the quadratic formula. So what I'm going to do, I want the x squared term to be positive. That's just me. So I'm going to get it to this other side. So I'm going to add 9x squared to both sides. I'm going to have 9x squared. And I'm kind of on the right side now. So I have 9x squared minus 16. And on the left side, I would have, we can just say 3x minus 6. Instead of -6 plus 3x, same thing. So I'm going to change my color. All right, so another step. So I'm trying to get standard form. So I'm going to subtract 3x from both sides. So that'll give me 9x squared minus 3x. And I have the minus 16, but I'm going to add 6 to both sides. So minus 16 plus 6 is minus 10. And this equals on the other side now, I don't have anything left. I have 0. So what I've done is I've moved everything together, and I wanted to get the x squared positive. That's why I added 9x squared to both sides. So what I'm left with is 9x squared minus 3x minus 10 equals 0. This is in standard form. When you use standard form, you can use the quadratic formula to solve. So quadratic formula, I hope I get it right off the top of my head. So it's negative b plus or minus the square roots of b squared minus 4ac, and that's all over 2a. So this is a formula that you can use to solve any quadratic equation that is written in standard form. Okay, and you can find this all on the internet, believe it or not. So what I'm going to do, so negative b is negative 3. So let me just get all my variables identified. So a is 9, b is negative 3, and c is negative 10. Negative 10. So what that's going to allow me to do is just plug everything into this formula. So negative b is negative negative 3. Those cancel to positive 3. So it's 3, I hope, and this is already looking like I'm going to need to reduce down the line, plus or minus the square root. What's b squared? Negative 3 times negative 3 is positive 9. And then it's minus 4ac. So it's minus, what's 4 times a times c? So that's 4 times a is 9 times c is negative 10. And this is all over 2a, which is 18. Because a is 9, so if you do 2 times 9, that's 18. So I'm going to try to simplify. So this is 3 plus or minus the square root, and this is going to be 9 minus a negative. So I'm going to end up adding the number because I'm subtracting a negative. I'm just going to add everything. 10 times 4 is 40. Actually, yeah, 10 times 9 is 90. Times 4 is 360. So this is looking not fun. Oh, okay. It's 360 plus 9, so 369. And I think that's a perfect square. I think that's actually maybe not. 169 might be. Either way, over 18. So let me see. So let me see if 369 is a perfect square. So let's do the square root of 369 is not a perfect square. That's all right. So we can simplify it. We're gonna need to find perfect squares within 369. This sounds like no fun at all. Looking at my answer choices here, I like D. I'm seeing a 6, so I'm thinking maybe I'll divide something by 3. So what I'm gonna do is I'm gonna see if 9 is a factor here. So 369 is 9 a factor? 369 divided by 9. Yes. So what I can do is I can rewrite here. So it's 3 plus or minus. And what I want to do if I'm trying to simplify the square root of 369, I want to find a perfect square within 369. So I'm going to split it up into the square root of 9 times the square root of 41. 9 times 41 is 369. If you're simplifying a square root, you can split it up into 2 square roots as long as the numbers inside the square roots multiply back to the original number. And this is over 18. So what this allows me to do is it allows me to say this is 3 plus or minus 3 square roots of 41 because the square root of 9 is 3, and that's over 18. Now what I can do is kind of cancel out because I have a common factor of 3 here. I can say 3 over 18. I can divide top and bottom by 3. So that's going to give me 1 over 6. And then that's going to be plus or minus. And then the 3 square roots of 41 over 18, I can also cancel. I can also divide top and bottom by 3. So it's going to give me the square root of 41 over 6. I could split this up into two fractions, but it's also 1 plus or minus square root 41 all over 6. To me, this is looking like D. And I know the negatives. With a negative over a negative, that's going to cancel out to a positive. So I think this is all going to work out fine for us. So I like D as an answer here, and I hope that it gives it to us. Oh, thank you. So this question says the power generated by an electrical circuit in watts as a function of its currents, X, in amperes, is modeled by P of X equals negative 15X times X minus 8. So we have a function here. And let's read it again. It's the power generated is a function of current. So X is the current. How strong is the current? And what it's going to give us when we do this math is how powerful the circuit is. So what is the total power of the circuit? This function is quadratic, and I see a negative in front of the X here, negative 15. It's going to give us a downward shape U. So the maximum is going to be at the middle, at the vertex. That's going to be where the maximum is. So to find the vertex here, what I'm going to do is well, looking at the structure of this quadratic, if I want to find the solutions, if I want to figure out when will this thing equal 0, from this factored form, I can plug in 8 as one of my numbers. So if X is 8, the whole function will be 0 because 8 minus 8 is 0. So one of my solutions is at 8. 1, 2, 3, 4, 5, 6, 7, 8, like that. And the other is at 0. If I plug in 0 for X, I will also get 0. So if I put in 0 current, I'll get 0 power, I think, and that makes sense. That makes sense to me. So the y-axis is measuring power as a function of current, and the x-axis is showing what is the current. So this function, it goes up and down, but the solutions are 0 and 8. So the middle is going to be where x equals 4, right in the middle of this. So to find the maximum power, what I'm going to do is I'm going to plug in 4 for x, because the maximum power is going to occur when x is 4, when the amps is 4, because that's right in the middle of the two solutions. Yeah, it's going to give us the vertex. Okay, so when x is 4, all I'm going to do here, I'm actually going to erase. So all I need to do is plug in 4 for x. So I'm going to get negative 15 times 4 times x minus 8. So 4 minus 8 is negative 4. Okay, so I'm going to get negative 15 times 4, which is negative 60. So it's going to be negative 60 times negative 4. That's going to give me positive 240. So hopefully that's my answer. So when x is 4, when I put in 4 amps, I'm going to get 240 watts of power. I hope. Yeah. Let's take a look at this one. All right. So this is an equation, and it's like a quadratic it's equation, and we're trying to solve it. So there are different steps you could take here, but what it's asking you to do is kind of put steps in order that would work. So what we're going to try to do to isolate this x is you kind of want to clean up everything around it until you can take the square root of both sides. Once you can take the square root of both sides, you're going to get positives and negatives. That's how you're going to get your two solutions. But let's just kind of think about how you would start to solve this. If you want to isolate the x, I think the first thing you'd probably do is add 5 to both sides. That's just going to give you your constants all together on the right side. So you'll be left with 2 times x plus 2 squared equals, add 5 to both sides, 98. So as a first step, I like add 5 to both sides. I think your next step here, because we want to be taking a square root, but that 2 on the outside is kind of messing with us. So I would maybe divide both sides by 2. So I would probably divide both sides by 2 here. What that's going to do is if you divide by 2, get that in, divide by 2, it's going to cancel out this 2. So it's going to give you x plus 2 squared equals 98 divided by 2, so that's 49. So from here, if I'm trying to solve for x, it's in parentheses, and that is squared. So the logical thing to do would be to try to get rid of this squared, is to take the square roots, and that does work here. We can take the square root of both sides. So let's take the square root of both sides. That's going to give us the square root of x plus 2 squared is just x plus 2. And the square root of 49 is plus or minus 7. So it's 7 or negative 7. This is how you're going to get two answers, which is typical in a quadratic equation. To solve here, all I'm going to need to do is subtract 2 from both sides. So I think that's going to actually be my final step, because if you subtract 2 from both sides here, that's going to leave you with your two answers. X equals, it's going to be 7 minus 2, so 5, or negative 7 minus 2. So the other answer is negative 9. So you get two answers, and that's the last step. So I think those steps in that order are going to work.